All right, I'm now going to do 9 through 12. 9 through 12. How do I find the inverse? Think of this as a y. First thing I'm going to do is switch the x and the y, and then I'm going to isolate the y. So I'm going to do PEMDAS backwards. That means I'm getting rid of adding or subtracting on the same side as the y. Then I'm going to do multiplying or dividing to isolate the y. Nothing more I can do here. So the inverse is equivalent to this. How do I correctly write it? The inverse of function f of x, and that's how we denote the inverse of that negative 1 in the exponent position, is x plus 7 over 2. Let's now find the inverse for number 10. So I'm going to start by switching the x and y, and then reminding ourselves we're going to do PEMDAS backwards. So I'm going to start with adding or subtracting outside of the parentheses. There's only dividing by 2, so there's no adding or subtracting on the side that contains the y. This is inside the parentheses, it doesn't count. Opposite of multiplying and dividing. Opposite of dividing by 2 is multiplying by 2. Multiply both sides by 2. Notice I've already switched the x and y like I initially did in parts, question number 9. So now we have 2x equals y minus 3, and that quantity is cubed. Next up, exponents. How do I remove this 3? There's a couple different ways we can do that. And so I'm going to write down both ways because it depends on how you connect to this. And either way would be right. Some of you like to do the cube root. So the cube root on both sides. So this would be that small nth root is going to be a 3. And then my last step would be to add 3 over. So one answer could look like this if I write above. One answer could be the cube root of 2x. I'm moving that 3 over plus 3. That's one form of this. The other way to write this is to raise it to the reciprocal. So the reciprocal of 3 over 1 is 1 over 3. So 2x raised to the 1/3 equals y minus 3. Now we add that 3 over last. So 2x raised to the 1/3 plus 3. Either one of these would be an accurate way to represent the inverse. You don't have to do them both ways, just one way. Let's look down right now at number 11. How do I evaluate this function when I substitute n plus 2 in for x? Okay, so n plus 2 quantity squared, n plus 2 quantity squared minus 4 times quantity n plus 2 plus 7. I'm going to write this out twice. Take that base and write it twice. Now I'm going to FOIL this front, outside, inside, last. So front, outside, inside, last. And I'm going to distribute to get 4n minus 8 plus 7. And now I'm going to go ahead and combine like terms. So f of n plus 2 equals n squared. Okay, 2n and 2n is 4n, but 4n minus 4n is 0. I could put plus 0n, but that's not necessary. 4 minus 8 is negative 4, and negative 4 plus 7 is positive 3. All right, let's do the part B of question 11. Same concept. Give myself a little more space here. Negative 2n squared. I need to square that. Subtract 4 times negative 2n squared plus 7. So I'm going to write this base twice. Okay, and I forgot those squares inside. There we are. Okay, negative 2 times negative 2 is positive 4, and I have a total of 4 n's. When you have the same base you're multiplying, you add the exponents. Now, negative 4 times negative 2 is 8 with n squared and 7. I cannot combine anything else within this problem. Let's look at number 12. Number 12, we need to find the inverse of this. So let's start just like we did with question 9 and 10. Let's switch the x and y. X equals y squared minus 9. I'm going to add 9 to the other side as I work on isolating the y. X plus 9 equals y squared. I'm going to take the square root of both. I'm going to have two answers here. So there will be a plus or minus. The square root of x plus 9 is equal to y. Now, as we go through this, notice that we are limiting the y's to being greater than or equal to 0, so I don't have to put the negative here. We're not accounting for the negative. So this is my answer. We're not accounting for the negative. That's what this says. Only greater than or equal to 0. So, okay. So in this case then, we have that the inverse of f of x is equal to the square root of x plus 9. Okay, now for this, what is our domain? So we have rule number 2 here that we often see on the board, which is n must be greater than or equal to 0. So x plus 9 must be greater than or equal to 0. So x is greater than or equal to negative 9. We could represent it on a number line if that helps you. And so in interval notation, we could also represent it as all values greater than or equal to 9.